Okay, now we learn how to find the t value and the z value. The t is for t distribution and z value from normal distribution for a given confidence level. Okay, we look in the table. We first calculate the area, and we look in the look up the table, and to get the t value or z value. Okay, next we are going to use this t value and z value to estimate the interval where the population means lies in. Okay, here's the way to find it. There are three cases to find the interval estimation for population means. Okay, the first case, case 1, we estimate a population mean when sigma, which is the population standard deviation, is known. If we know sigma of the population standard deviation here, then we can follow case 1. It doesn't matter how many objects in your sample. Okay, if we know sigma, then we can use case 1. Okay, in this case, suppose that x follows normal distribution with mean mu and standard deviation sigma. And if we know the value of sigma, then we can use the central limit theorem, and which states that x bar, which is the mean, the sample mean right here, follows the normal distribution with mean mu x bar. Remember this at the beginning of the chapter. And the standard deviation sigma x bar. Okay, and we know that the sample mean, the mean of the sample mean right here is gonna be exactly the same as the population mean. But the standard deviation of the sample mean is going to be sigma over square root n. And for the z-score, to find the z-score, it's going to be x bar minus mu x bar over sigma x bar. Okay, and if it falls in this case, the confidence level with the confidence level of 1 minus alpha, then the confidence interval can be computed this way. Okay, mu is going to fall between x bar minus z alpha over 2. This one you need to look up the table just the way we did before, times sigma over square root n, and then less than mu, less than the upper bound is going to be x bar plus z alpha over 2 times sigma over square root n. And we can derive this interval on the next page. Okay, suppose we know that confidence level is 1 minus alpha, then what we are looking at is we looking probability of z, okay, between these two values, z between minus z alpha over 2 and then less than z alpha over 2. So it's gonna be 1 minus alpha, right? Okay, we set up this probability. Okay, probability here from z from here to here. Okay, it's going to be 1 minus alpha. Then we convert this, since z is x minus mu over sigma, right? But it's gonna be z of the sample mean. Then we convert this, okay, to the normal value. Okay, not the standard one. The standard one converted to non-standard. Okay, so it's like this, keep falling this way. Since mu x bar is mu, we sub this, and sigma x bar, we are going to substitute the value here too. So from here, if we figure out this value, you can multiply. Okay, this is inequality. You multiply sigma to the left and to the right. Okay, so it's gonna be z times sigma, then mu you swap around, and it's gonna be this way. okay? If you solve this inequality, it will give you the next line. So mu will be like that. If you do the math, then minus mu is gonna be less than z alpha over 2 times sigma x bar minus x bar, and on the left, and then we will swap the sign around, times sigma x bar minus x bar, and then when you multiply -1 to the whole thing here, then you swap you swap the inequality around, okay, and you will get this one. This side will be this one if you multiply by -1. Okay. After all, you get this, and the interval in here, we call it confidence interval, okay? So mu is going to be between these two values, or we can write down mu equals x bar plus or minus this one, okay? And this term is actually we call the error term, okay? The error E. Some book call this E, and for C, this value, you need to figure it out. Alright, in case 1, like that, okay? If you know sigma, then we can use this case, okay? The interval estimation of the population mean would be this guy. Let's see example, okay? Example 3. This is confidence interval. Example 3, consider we have 15 birth weight of the girls given in for which n is 15 and x bar is the sample mean is 30.9, Hg is hectogram, which is 1 hectogram is 100 gram. Construct a 95% confidence interval estimate of the mean birth weight, okay, the population birth weight of all girls, assuming that sigma is known to be population standard deviation. Assume that sigma is known to be 2.9 Hg. Interpret the meaning. We need to interpret the meaning, okay? So from the question, write down what we know. We have n is 15, x bar, which is the sample mean, okay? Sample mean is 30.9, and sigma is 2.9, okay? Sigma is population, SD standard deviation. So since sigma is known, then this one falls into case 1, okay? This is case 1. Then we can use the formula in case 1. So the key point is you need to figure out that alpha over 2, because other value you can just plug in, but this one you need to look up the value. So to find that alpha over 2, just like what we did in example 1 and example 2. So 1 minus alpha is 0.95, so alpha is going to be 0.05. Alpha over 2 is, we did this many times, 0.25. So we look for the C value so that the area here, C alpha over 2, so that the area here is 95 plus another 0.025, So area is going to be 0.975. Okay, so from the table, which we did many times, or you can look at the table here because they already put it up. So 95% Z is going to be 1.96. Okay, so from the table, excuse me, Z alpha over 2 is 1.96 because P of Z less than 1.96 is 0.975. Okay, so confidence interval for mu, we are looking for the population mean, okay, of all girls. The formula is mu less than x bar minus Z alpha over 2, okay, sigma over square root n, and then less than x bar plus Z alpha over 2 times sigma over square root n. So mu is gonna be greater than substitute 30.9 for x minus z is 1.96. Sigma, we know it as 2.9. Square root n is square root 15. Less than x bar is 30.9 plus 1.96 times 2.9 over square root 15. All right, this value, if you calculate it, this value is 1.4676. Let me add a page. Okay, example 3 still. So mu is going to be greater than, if you calculate the values here, okay, calculate the value, you get 29.4324 and less than 32.3676. So interpret this means we are actually 95% confidence that the population mean, okay, lies in the interval 29.4324 and 32.3676. Okay, the mean must lie in here. We are 95% sure. Okay, 95% confident. And here we call it confidence level, confidence interval. Or CI, okay, with 95% confidence level. Okay, hope you understand this. It just plug in the value. You need just, what you have to work out is this guy. This is the hardest part. After that, you just plug in the value and you get the interval. All right, this is the first case. If you know sigma, then use this. But if you don't know sigma, we come into case 2. We split into case 2 and case 3. Okay, if we don't know sigma, sigma is not known. okay, to estimate population mean when sigma is not known. And we know that n is greater than or equal to 30, and we call this a large sample. So if your n is 30 and above, then we use case 2. Okay, if we don't know the value of sigma, then we use standard deviation of the sample mean right here to represent sigma. All right, we do it in a similar way, just change sigma to s. Okay, then from the central limit theorem, then x bar, the mean of the sample mean right here. Okay, x bar follows a normal distribution with the mean of the sample mean and standard deviation of the sample mean. See, same here, but sigma, change it to here. Okay, for the first case, sigma is actually sigma, right? Population standard deviation. But in case 2, we don't know population standard deviation, so we use just S. Okay, the sample standard deviation to calculate the standard deviation of the sample mean. SAT is still x bar minus mu over sigma x bar. Okay, in this case, the confidence interval is quite similar to the case 1 except this guy. Okay, the things that change is this S value. Instead of sigma, we use S. Alright, so the rest will be the same here. We do the same thing here. We set up inequality and we simplify it, we move it around, then you get the confidence interval. We use sample standard deviation for population SD. Okay, just here. The difference is here. Alright, this is the second case. It's not that hard. Okay, let's see. Example 4. We have a sample size of 49. Okay, n is 49, right? And we have sample mean of 35 and sample standard deviation. We don't know population standard deviation, but we know standard deviation of the sample, and it is 14. Sorry. Construct a 98% confidence interval for the population mean using this information. We don't have 98% in the table. I mean, in the table before, where is it? We don't have we have 98%. Okay, lucky us. Okay, we will work on example 4. Write down what we know. N is 49. So, n is greater than 30 for sure. This is large sample. Okay, large sample. And we know x bar is 35. And we know that standard deviation is 14, standard deviation of the sample. Now we need to figure out, we will use SAT, normal distribution, right? So in this case, x follow normal distribution with mu x bar and sigma x bar. Okay, so we find z-score. 1 minus alpha is 0.98. So alpha is going to be 0.02. Alpha over 2 is 0.01, right? So here we need to look up the tables, but we have it already, right? So 0.98 here plus alpha over 2, 0.01. Okay, we're looking for SAT alpha over 2. You can write loud like this. Right? So looking for the area here. So area is 0.99. And from the table, go up. From the table, C is 2.326. Okay, I'm going to use the C score here. From the table, okay, Z.01 is 2.326. Okay, we just look at the table. So confidence interval it's going to be between, okay, mu greater than x bar minus z alpha over 2 and s over square root n, and less than x bar plus z alpha over 2 times s over square root n. So substitute the value. X bar is 35 minus z 2.326, s is 14, square root of 49, which is 7, and less than 35 plus 2.326 times s, which is 14, square root 49. Okay, and this value is 4.652. If we calculate the value, mu is between 30.348 and 39.652. Alright, we are done. So right now, we interpret this. We are 98% confidence. Okay, that the population mean or mu lies within the interval 30.348 and 39.652. That's it. All right, this is the second case, and I think we should stop here and we will continue case 3 in class.